Okay, thanks, Brent. Thank you all for being here. So what I'm going to go ahead and show you all right now is I want to show you the workflow of SS3, and that way you get a good idea of how everything kind of plays together. So what I'm doing is I'm starting off by creating a terrain model, and the terrain model is basically our survey now. So what we do is we just got to import our tin, and I'm going to show you how to do that. Right now what I did was I went ahead and started by creating a 3D seed. Now the terrain model is going to be the only thing that uses a 3D seed. You really don't need a 3D seed for anything else. And I go ahead and go to create from file, and I go to workspace preferences. I want to make sure that I use the Windows file open dialog box checked on. And then I'm just selecting my tin, and I'm going ahead and importing my tin. All right, so I'm going ahead and putting the units as a US survey feet, and I'm selecting a feature definition of existing boundary. And that's just basically a level that you could use. I think that's better. All right, I went ahead and zoomed extents just so you can see everything. I'm trying to rotate just to show you all that it's in 3D. And then what I'm going to do is now I could just turn on the triangles, and I can also turn on the contours. So that's basically here you could see everything in your survey. You could see a point that may be off or something that just may not look right. It could easily stand out to you. You could turn on a shaded view so you can see everything nice and smooth as well. And you can see shadows and everything. It looks pretty cool, actually. You can see a lot of good stuff. What I'm going to go ahead and do now is I'm going to turn on my contours so that I could actually see the contours on the fly, and I could change the major minor intervals very easily. So I'm going to element information as I select the contours, and I'm changing my major interval from 5 feet to 1 foot. I'm going to change my minor interval from 1 foot to 1 inch. And it looks really smooth. Now, those text that was really large there is from annotation scale, so I go ahead and I'm just going to go ahead and turn that off. So that's about it for the terrain model. We're going to just import our tin, and we'll be done there. So what I'm doing is I just went ahead and cleaned it up, put existing boundary on, because we're going to reference that into the rest of our DGNs. All right, and next what I'm going to do is I'm going to go ahead and import an alignment and profile. Now, this alignment and profile was done, for the most part, using SS2. And the reason why I'm showing you this is because I want you all to know that the SS2 tools are still there. You can still use them to create your alignments and profiles, whatever you're comfortable with. So I'm started a new DGN. I'm going to go ahead and use a 2D seed file. Now, as I mentioned, the terrain model is the only one that uses a 3D seed file. Everything else is going to go ahead and use a 2D seed file. And what I'm going to do after that is I'm going to go ahead and connect to the GBK. Well, right now what's going on in the video actually is I'm just importing or referencing in the existing terrain so you can actually see the area that I'm working with. All right, now I went ahead and going to classic tools, and I'm connecting to my PRJ. Now this is a dialog box everyone's familiar with. All our tools are still there. You can do the report cross-section quantities, you can do the vertical alignment generator, everything is still there, so you all can still use that. Now the main difference though between the new software and the old software is the cross-sections. So your shape files are not going to be there, your criteria files, thank God, are not going to be there. At least that's my opinion. All right, so right here is I'm just going ahead and I'm starting I connect it to my GBK, and I'm going to go and select the profile I wish to import. And it goes ahead and it selects the actual alignment that's associated with that profile, and it brings it into the DGN. Now what I'm showing you here is the profile view in the top right corner, and the existing ground line's not there, so I just need to turn on my terrain model to make it active, and my existing ground automatically pops up. Now, just showing you here that the model space created a 3D space automatically. So in a 2D seed, anything that gets a Z value will automatically create a 3D model space. Treat those two models as completely different DGNs because they're completely different model spaces. All right, I'm going to go ahead and create an edge of pavement. Now, I like creating a separate edge of pavement file. Some of y'all in your training may hear differently. And the reason why I like doing that is because I feel it's a good basis for everyone to connect to. You can see where the main lanes may change or the frontage road may change, and it's not all necessarily connected to your template. So that's what I'm going to go ahead and create an edge of pavement file. And it's a little bit tricky, right? Because I'm using, for horizontal geometry, I'm using the horizontal geometry tools. And for vertical geometry, I'm using the vertical geometry tools. Yes, very good. All right, so it's pretty simple. A lot of these tools are named pretty straightforward. You know, it's not very hard to tinker around and get something done. All right, what I did was I just used a variable offset taper tool on my vertical alignment, and I transitioned my roadway from an 18-foot roadway to a 30-foot roadway. So let's say I'm tying into an existing road or something. and I mirrored that, so that's why those two blue lines are showing up. I gave a feature definition to them of road edge of pavement, just so that they could distinguish differently from my road centerline pavement. All right, and then I went ahead and just completed off that offset. Those yellow lines that you see there, those are the rules. So I could easily go to those yellow lines. I could change the 30-foot to a 24-foot if I wanted to. All right, so I just want to show you that that's what those yellow things are for. And then what I'm doing is I'm complexing that edge of pavement line into one single line now, so that it would be continuous. After I make that continuous, now this is just the horizontal geometry, right? I need to give it a Z value. So to give it a Z value, what I'm going to do is I'm going to use a profile by slope. Now this is just, don't go exporting the profile by slope right now, but you could give your edge of pavement a profile by slope. So I'm going to say a 2% cross slope across the road, and it goes ahead and profiles that edge of pavement at 2%. Why are you giving your profile to the edge of pavement? Why are you doing that? Well, with the 3D model, what you could do is you could easily reference in that edge of pavement to, let's say, your ditch line. Let's say you want to stay 2 feet below your edge of pavement, right? That's the upper bound for your ditch line, or you don't even want to be there. So you could easily reference that in and see it in multiple views. And also, if you have an intersection that you need to tie into, the intersection could tie into that edge of pavement, and it's just overall good to give it a Z value. What I did here was I just did a right-click view 2D, 3D, and so the 3D view actually pops up on the right-hand side here, and that's actually the 3D model space, so treat it as a separate DGN. Next, what I'm going to do is I'm just go ahead and create a ditch line alignment and profile. So I'm just going to, again, use my horizontal geometry tools to find the location of my ditch line. I'm going to offset it about 60 feet from the center line of the road, and I'm just going to go all the way through to wherever I believe my ditch should be. There's no ditch on the right hand of my DGN, so I just stopped it a little bit early before a bridge. Now what I got to do is I'm going to bring up the profile view for this ditch line, and I'm going to see, you can see here that the existing ground's there, and that's because my terrain is set as active. All right, next what I want to do is I want to reference in my edge of pavement profile into this view too. Now, this is going to be the way or the process that I see us using in the sense of referencing in multiple profiles into, like before, like you had your vertical alignment generator, the green cell, and you need to plot multiple profiles. I see us doing it more like this. That purple dot that you see there was the actual flow line that, of a culvert that was there, so I want to know where that is. That green line up top that's pretty smooth is our edge of pavement that was referenced in. I did a profile by slope saying it was a 0% slope. Then what I did was I went ahead and offset that 2 feet to say that's my upper bound. I don't want my ditch line to go more than 2 feet within my edge of pavement. So then what I did was I went ahead and just select the feature definition, grade ditch bottom. That's very important. This is the feature definition I selected. And I clicked that chain on the top right-hand corner over there. It's kind of a little difficult to see. And what that little chain there does, it allows me to easily go ahead and just nonstop draw my line all the way through. And I just snapped to locations where I thought my ditch line should be, and everything looked like it was underneath the edge of pavement, and it was fine. I'm going ahead and complex that line now into one single element, and I'm going to set it as active. Also, what I got to do is, let's say I want to be able to, well, I'm going to have to put this on my profile sheets, right? So I have to export it to my GBK because I'm going to be using my DNC manager to draw out all the alignments and profiles. So what I did was I gave it a feature name of ditch bottom. Then I'm just showing you right here under the properties display, it shows you the rules associated with those lines. So this one's showing you it's a 2 foot offset from my edge of pavement. And there you go, now I have a ditch line created. Next is the creating and modifying a corridor. Now this part is basically our cross sections. This is the key to the new software. This is what's brand new. So I'm going to go ahead and create a corridor across the whole thing. But first I want to show you a template dialog box. This is what my cross section is going to look like. Basically anything that's closed is going to give me cubic yardage. Anything that's aligned could give me square foot. And all those points there are all constrained, right? So each of these points, that point right there has a horizontal constraint and a slope constraint. It's a little blurry to see, but those are 2 constraints. And then there's labels here at the bottom. What those labels are, those are parametric constraints. What that allows me to do is just click on my corridor anytime and change the values. Now what that is that's an end condition, and an end condition could target a terrain model, it could target a feature definition, it could target elevation. In this case, it's just going to target a terrain model. And then on the right-hand side, I'm going to get it to target a feature definition of grade ditch bottom, right? Because that's what we want to tie into. So next what I'm doing is I'm going to go ahead and just drop my template across the whole corridor, just kind of like you're running your hinge criteria file across the whole project, just to check everything out. And you notice in the top right-hand corner here, the pavement's not connecting correctly because it's at a 30-foot offset. What I'm going to do is I'm going to use a parametric constraint from station 0 to 9 to transition it from an 18-foot to a 30-foot. And that parametric constraint is going to change everything and make it look a lot nicer. Another thing that we're going to be using parametric constraints for is, let's say pavement design changes at 90%. That doesn't happen, right? But let's say it does. You could put a parametric constraint on your pavement to change it from 17 to 24 foot. Next, what I'm going to go ahead and do is I'm going to do a copy template drop. So right here, what this is, it's a little difficult to see, but this is supposed to be a bridge section actually, and it's not represented very well. So what I'm doing is I'm breaking my corridor, and I'm placing a new template in between these. It's still a solid corridor, I'm sorry, but there's a different template between the two. I'm going to the properties, and I'm just going to select the bridge template. And now this place automatically updates the new bridge template. And on this edge over here, I do not have a ditch bottom. It's just slopes. So I'm going to just switch this profile or this template to have slopes. Now the slopes are not connecting to the terrain. Why is that? Well, one, the terrain has to be active for it to connect. And two, if there's any changes to the corridor that are done, you need to reprocess your corridor. So that's what I just did right now. Now the slopes are connecting, but my grade ditch bottom is not connecting. Why is that? Well, so these are kind of like your DGN variables. So to acknowledge a DGN variable, you have to use a corridor reference. So I used a tool called corridor reference, and it ties in to the ditch line nice and neat. So next what I'm going to do is I'm going to go ahead and add a culvert. I know this was something a lot of people were interested in, so we tried fitting it into the presentation. I'm just changing up my save views to find my culvert location. What that blue line right there represents, it's a horizontal geometry line that has a vertical profile to it, and it's just basically my flow line. And what I'm going to do is I'm just going to drop a linear template across that. Now the linear template is the same thing as a corridor template, but it follows a line. All right, so that's just a multiple box culvert that I dropped on top of that line, and now you can see it's here. What I next got to do is I got to go put in a head wall and make sure everything ties in correctly. So what I went ahead and did was I created a cell, and eventually I see us having a library of 3D cells that we could use. And, well, in this case, though, I didn't have the library, so I tried creating one on the fly. And I'm going to go ahead and import that cell. These lines that I drew up here are just like key points that I know, all right, if I'm going to place my cell, I need to snap to these locations. And I drew it in my 3D view there so that way it's easier to snap. It's best to draw it that way. So I'm just snapping the two locations, and then the head wall goes in and pops in. So next what's going to happen is that my template is still tying into the existing grade ditch bottom, right, that feature definition. What I need to do is I need to switch that to tie into the back of head wall. Well, to tie into the back of head wall, what I'm going to have to do is I'm going to have to create another alignment around the top of that head wall and give that a profile. Now, it sounds a little tedious, but it's not that bad. What I went ahead and did was I have these construction lines popping up, and I select my horizontal geometry, and I'm just snapping to the end of these lines here, and then my horizontal geometry is created. Now, each of those lines I created is separate, so what I got to do is I got to complex it into one. When you're complexing things, make sure you have that arrow facing the same direction. You don't want them conflicting each other. So next what I'm doing is I'm bringing up the profile view, and for the profile view, I'm going to do the exact same thing. I click that chain again, and I'm clicking a line, and then I'm going to snap to these corners here, and it's automatically going to draw it in my profile view here. So you could do this if you're trying to snap to an existing retaining wall, or you want a specific elevation. You can visually see what you want to snap to, and then just go snap to it in your 3D model, and it'll locate it. I went ahead and complex that to make it one single line. So now I have my line drawn, and the template is still not going to be updated. Why is that? Well, one, I have to reprocess the corridor. Two, I probably have to change the template drop that's on there. And three, that line that I just drew is not a corridor reference to my template. All right, well, and then there's another one. So what I want to show you here is just basically that it's not connecting. Now, the way these templates work is they're placed every so many feet. You say 10 feet, 20 feet, whatever it may be. But what I want to show you is that these green lines here each represent a separate template drop. And then the software interpolates between those two templates. So what you need to do is, if I want this back of head wall to be red, I need to drop more templates along that area. So yeah, don't panic. It may look a little funky at first, but it's because I still need to add that as a corridor reference. So I'm going to go ahead and add that, and then the templates are spaced out. So I need to click on my corridor, and right now it's going to be at a 30% design model. I want to switch that to a 90% design model, and it's going to increase the amount of templates. So you'll see that shortly. And now that the templates get dropped, it's going to clean up a lot nicer. So there you go. Now you still have those key areas that still kind of a little messy, and you're like, oh man, I need a template right here. So you use a tool called key stations. So I went and clicked that, and then I clicked the location I want, and now it's cleaned up. So I went in, and there you go. I have the culvert already in place and the head wall set up. Next, what I'm going to do is, well, I'm turning off the construction lines just to make everything look a little bit better. And what I want to show you next is going to be dynamic cross sections. Dynamic cross sections are a great tool. You could utilize them very well. And so I'm selecting that. I'm going to go ahead and put it down here in this bottom view. Oh, actually, I'm just going to show you the components. I could click on my corridor, and it'll give me cubic yardage and square feet for everything. And I could put in a price for each of those units, and it'll give me a total project cost along that corridor. So, all right, now dynamic cross sections. Sorry, I jumped the gun there. So I went ahead and put it in this view down here, and you can easily just see a cross section anywhere. The benefits to dynamic cross sections is, one, you can see if your template is working or not. So you can see if things are tying in. Two, let's say you want to check a horizontal clearance, something, or you just want to verify that this flow line is going in the right direction. You know, you can bring all that up and just see that on the fly. So dynamic cross sections are a really big help. Can you fit a retaining wall in there? Do you fit a slope in there? What do you got to do? Next, what I want to show you is just cross sections in general. So guys, we still could create our green cell cross sections. Those green cell cross sections, we can still run our old tools off of that too. For example, HEC-RAS or whatever we got to do. What I did was I selected on preferences, and I just put stacked 10-foot cross sections. And then I'm going to go ahead and select the model name that I wanted to create it under. And I put a vertical exaggeration of 10 on there just so it looks a little bit neater. So you see, these are the cross sections we're all used to seeing with the green cell. I'm bringing up my classic tools here. I have all mode tools. I'm going to bring up the cross section navigator, and then you can easily just flip through all the cross sections. So I thought that was really good. It's still a really good benefit, because I still personally like to use a lot of those old tools when just checking to make sure everything's tying in correctly. Now, the thing that's going to be a little bit different though is earthwork. So for earthwork, you're going to have to actually, if you go with this new method, you're going to have to use the new earthwork procedure. And that's just because these, like I said, these shapes are all created from their corridor model, and we're used to having just undercut lines. So unless you're going to go draw each and every undercut line, that's up to you. I wouldn't recommend that, probably. So what I'm doing here is I'm just bringing up the earthwork dialog box. I'm going to just change all my components to, well, one of them to MDC. MDC basically classifies everything separate from the rest of the quantities. So I have cut and fill separate. And so I'm going to go ahead and go to my volumes report. Now the new report is going to have a list of all my components. It has the volume. I'm switching the units to cubic yards. Just make sure you're in cubic yards. They'll tell you up here. And so there you go. You could actually check your earthwork quantities like that. All right, guys, so that's how you create the model. Next, I'm going to go ahead and pass it on to Daniel, and he's going to show you the great work that everyone is doing across the state.